Right. So looking at similar shapes. In this case, they're triangles. They're often triangles. Don't have to be triangles, but these are similar shapes. Let's just recap the difference between similar and congruent. Congruent means basically, I guess you could say exactly the same. They're the same shape and they're the same size. Whereas similar just means they're the same shape, and so one could be larger than the other. If they were similar, all the angles would be the same, but the sides wouldn't be the same. However, the sides are going to be they're going to have a magnification. So if one side let's take this triangle over here. These two triangles are similar, but they're not congruent because this triangle 2 is bigger than triangle 1, quite obviously. But they are similar because all the angles are the same. And what happens then if they're similar is if I were to triple side this left hand side, this one that I've coloured in pink, then all the other sides would also triple if it's a similar triangle. So this side was 3, now it becomes 9. Okay, so that we can say, yeah, you got a scale factor of 3. Okay, so or magnification of 3. So what you've done there is you've taken one of the sides and you divided it by the other corresponding side. 9 divided by 3, you can take 6 divided by 2, and you got the scale factor is equal to 3. So the first thing really is to identify what is the scale factor, and then you can work out the missing side. So if we look at these, and this is going to link to ratios a lot. So if we take these two triangles, I've color coded them so we can see which side corresponds to what. And the 8 is changed into a 12. So the ratio of the two sides would be 8 to 12, and that can be simplified by 2 to 3. And so the 5 to x must also be the same ratio, 2 to 3. So if we use this visual idea of what 2 to 3 means, we can say any numbers, when we're comparing one thing to another, we can take the one thing on the left, chop it into 2 chunks, and on the thing on the right, we'll have 3 of those chunks. So 8 to 12, chop it into 2, but each chunk must be 4, and then the right-hand side will be 3 chunks because it's 2 to 3. In this case here, the simplified ratio, the boxes are just 1, right? 1, 2, 2, 1, 2, 3, 3. Okay. If we do the same with the 5, then chop it into 2. Each chunk must be 2.5, and so you got 3 lots of 2.5 on the right, so x must be 7.5 because that's 3 times 2.5. So that's how we do this one here. At least that is my way of doing this one here. Then this one ends up, it looks a lot more difficult, but it actually in some ways ends up easier because you got these like complicated 3 to 6.6, which looks awkward as anything. But we're going to just take the 3 to 6.6 and then we're going to turn it into whole numbers and try to simplify it. Multiply it by 10 to start off with to get rid of the decimal point. Go to 30 to 66. And then we're going to simplify it by just dividing it by 3 because we can see they both divide by 3, 10 to 22. And then we simplify it again. We can see they both divide by 2. And we end up with 5 to 11. And we go, oh, hang on a second. 11, that says 11. That must be, hang on, does that mean that y is equal to 5? Yeah, y is equal to 5 because the ratio of the two triangles are 5 to 11, which is what we've identified by comparing the 3 to 6.6. So the ratio is 5 to 11. We already have 11 over here, which means that must be 5. If it turned out that this was, a way of making this question harder would be, let's say that was 33, then what would this side be then? If that was 33, what would this be? Yeah. What? Hang on a second. 15. Yeah, because it's 5 to 11, so it's basically it's 15. Yeah. Okay, so that's basically scale factors, and let's actually identify the scale factors in each of these cases. Actually, so you take one number and you divide it by another. There's probably another way of doing this actually than what I've just done. I've done it using the ratios, but anyway. So we've got I've just worked out a way that you can do it using the scale factor way, but never mind. So you go 12 divided by 8, and that's going to be equal to... so the scale factor is always going to be the one of the sides of the triangle. So one of the sides of the right hand triangle. If we're going to, it depends what we're saying. Are we comparing the right triangle to the left triangle, or the left triangle to the right triangle? I think we're comparing the left to the right, and in which case we're going to say how much. What we're saying is how much would I have to multiply each side by to get to this right triangle. So when we get the 12 divided by the 8, and that's going to be 1.5. So now I'm going to actually see another way, maybe the way that you probably were taught it at school, actually. So I'm going to then, to identify what the other triangle, or what the other side is, the x, I'll just multiply it by the scale factor. So 5 times the scale factor, 1.5, which is 7.5. Okay, there you go. So we can use that way of doing it, maybe, because does that sound more familiar to the way you were doing it at school? Yeah. It did suddenly occurred to me after doing the ratio way that's actually probably a better way to do it. Anyway, so we did the same sort of thing here. What's the scale factor here? Well, we've got the new side of 6.6. The old side is 3. So we go 6.6 divided by 3. And what's that going to be? Oh, it's going to be 2.2, isn't it? So 2.2. So the scale factor is 2.2. Let's see if this works out. But this time we're dividing it. Okay, all right. So you're going backwards. Okay. What I'm doing the scale factor here. This is 2.2. This is going from left to right. I'm going the other way around. Actually, what you would do if you want to go the other way around, you just do 1 divided by 2.2. To be honest with you. Because otherwise I would just do 3 divided by 6.6. But so 1 divided by 2.2, let's just do that on the calculator. Let's do it on the screen, actually. You can't see this because I'm not showing my screen at the moment, but I've got a calculator out right now. So 1 divided by 2.2 is equal to 0.45. So going back the other way, I forgot what I was doing for a moment then. Going back the other way, the scale factor so let's say this is triangle 1, this is triangle 2. So the first scale factor was going from 1 to 2. Right? Now we're going to go from 2 to 1. So the other way. So the scale factor this time is going to be 1 over 2.2, which is 0.45. And therefore, to identify what y is, you multiply the 33 by the scale factor. So I hope I'm doing this right. I've got this funny feeling I've missed something out at some point. Let's see. Hang on. Oh, what's going on now? Hang on a second. Right. So I accidentally did use the 33 instead of the 11, so I confused myself for a moment there. So let's just... Why isn't it? Okay, let me just get the eraser. So yeah, so we're doing 11 times 0.4545, etc., and basically you end up getting 5. So that's the answer. So when we're trying to go from one thing to another, if we know what the scale factor is, we multiply the side by the scale factor, and then we get the side of the thing that we're scaling. In this case, if the magnification or the scale factor is less than 1, then we're shrinking it. If it's more than 1, we're increasing it. So if it's exactly 1, we're not changing the size of it. Okay? Right. So let's just stop that.